you all for this lecture series on 4G and 5G communication networks. In this lecture number 27, we will briefly discuss about command and control methods used in the spectrum allocation. The command and control method is a traditional approach to spectrum allocation which possesses challenges for 5G deployment. It involves dividing the spectrum into fixed bands assigned to specific services, ensuring exclusive use without interference. However, this method lacks flexibility, making it difficult to adapt to the dynamic needs of 5G networks. As a result, spectrum inefficiencies arise, particularly in balancing urban and rural usage. Understanding this method is essential to develop more efficient strategies for future 5G advancement. First, we'll see what is command and control method, which is used in the spectrum allocation of 5G. The command and control method, as I've said, is a conventional approach to allocating spectrum, which is which has got a significant challenge to the advancement of 5G networks. In this method, spectrum is divided into specific bands that are assigned to various communication services. What are all the various communication services, such as mobile networks, satellite, and satellite operations and broadcasting? These bands are exclusively licensed to authorized users, ensuring that they can operate without interference from others. However, this method lacks flexibility, making it difficult to adopt the spectrum to accommodate emerging technologies like 5G. As a result, urban areas often experience heavy spectrum usage, that is congestion, leading to congestion, while rural areas face underutilized spectrum resources, creating inefficiencies and limiting overall spectrum availability for 5G deployment. Next, the need for efficient 5G spectrum management. The rollout of 5G network is hampered by existing inefficiencies in spectrum management, with some regions still struggling to provide sufficient 4G services. Under the current system, once spectrum is allocated, it remains locked and cannot be easily reallocated, even if it is underutilized or needed elsewhere. So once if it is allocated, we have to use it, otherwise it will be ideal. To address these issues and promote 5G development, implementing spectrum trading could be beneficial. This approach allows for reallocation of spectrum, improving its overall utilization. Additionally, deploying sophisticated technologies is essential to optimize spectrum efficiency, reduce congestion, and facilitate faster and more equitable 5G deployment, driving national development and improving connectivity for all regions. Next, understanding the command and control attacks, that is C square we can say, or otherwise C2. C2 represents command and control attacks. The command and control, that is C2 or C and C, we can call it as C and C, is a technique used by the threat actors to manage and control compromised devices within a network, often executing through DNS and other covered communication channels. C2 allows attackers to deliver instructions to infected systems. The primary goal of these attacks include downloading additional malware, establishing botnets for widespread malicious activities, and exfiltration sensitive data. The mechanism used for C2 attacks can vary greatly, with attackers employing multiple covert methods depending on the attack's complexity and objectives. This flexibility makes a C2 attack highly adaptable and difficult to detect, emphasizing the need for comprehensive security measures. Next, C2 tactics according to the Mitri at ATT and CK framework. And the Mitri attack, that is ATT and CK framework, outlines over 16 different tactics used in C and C, that is C2 operations, highlighting the diverse methods adversaries employ. These tactics include using standard protocols like application layer protocol, employing methods such as data encoding and obfuscation to guide communications, and creating encrypted channels for secure transmissions. Other techniques involve dynamic resolution, protocol tunneling, and fallback mechanisms to maintain persistence. The use of proxies, remote access software, and web services further complicates deduction. Understanding these varied tactics is crucial for developing defenses against C2 attacks, as it equips cybersecurity teams with the knowledge to anticipate and counteract these threats effectively. Next, we'll see how a command and control attack works. This diagram shows the command and control attack process. Otherwise, we can call it as the workflow. It consists of both recruiting, command and control. This is the bot master. So various flow diagrams are here, and the command and controlled C2 attacks begins with the attacker. See here, begins with the attacker establishing a foothold on the target machine, often successfully bypassing advanced security measures like next generation firewalls. This infection can occur through various methods, including phishing emails. See here, that deceive users into clicking on malicious links or operating attachments that execute harmful code. Additionally, attackers may exploit vulnerabilities in browser plugins or other compromised software. Once the target machine is infected, it communicates with the attacker's C2 server, sending signals to avoid further instructions. Attackers use this communication to issue commands to the compromised device, frequently blending their malicious traffic with legitimate traffic such as HTTP or HTTPs or DNS, or to evade detection and remain under the radar. Next, full control and botnet creation. See here, we have in this diagram, we have the botnet is available. This will see. After establishing communication, the attackers gains complete control over the victim's computer, allowing them to execute any code at will. This malicious code often spreads to additional devices, resulting in the creation of botnet, an interconnected network of infected machines under the attack's control. Commands and control is one of the final stages of the attack kill chain. See here, kill chain, a concept introduced by Lockheed Martin, indicating that the attacker has successfully bypassed other security measures. At this critical juncture, rapid detection and prevention of C2 activities become paramount for security teams, as the attack can significantly mitigate the risk of extensive damage to network and its resources. Next, types of command and control techniques. Command and control attacks employ three primary communication models that dictate how infected machines interact with the CNC servers, that is C2, each specifically designed to evade detection. The first model is the centralized architecture, resembles a traditional client-server system where infected devices, once compromised, connect to a central CNC server to receive commands from the attacker. While this model is the most common and relatively easier to detect since commands originate from a single source, cyber criminals can complicate detection by utilizing load balancers, redirectors, and proxies to obscure their activities. The second model is the peer-to-peer architecture is decentralized, allowing infected devices to communicate directly with one another rather than relying on a single server. This approach significantly increases the difficulty of detection as attackers can only take down one node at a time. The P2P model often complements the centralized architecture in hybrid configuration, providing a backup communication method if the main CNC server is compromised. The third method is the random architecture is most challenging to detect because it transmits communications to infected hosts from multiple disparate sources such as IRC chatroom content delivery networks, that is CDN, social media comments, and email. By using widely trusted and commonly utilized platforms, attackers effectively obscure the CNC server's identity and the botnet's chain of command, thereby enhancing the chances of their success and evading security measures. Hence, the C2 attack can target a wide range of computing devices, including smartphones, tablets, desktops, laptops, and Internet of Things devices, IoT devices. IoT devices, in particular, are at increased risk due to several factors. They often have limited user interfaces that make them harder to control. They are typically designed with the inherent security vulnerabilities and may do not receive regular patches or updates. Additionally, IoT devices frequently share large amount of data over the internet, further increasing their susceptibility to C2 attacks. Next, what hackers can accomplish through command and control. The first one, the hackers leverage command and control technique to execute a variety of malicious activities. The first one is the malware delivery. Hackers can use command and control techniques to initiate the download of additional malware onto compromised machines within a victim's network. This capacity allows them to expand their control and facilitate further malicious actions. Next, data theft. C2 attacks enable adversaries to copy and exfiltrate sensitive data such as financial documents from infected systems. This stolen information can be sold on the dark web or used for various forms of fraud. Shutdown. Attackers can remotely shut down individual machines or entire network, disrupting business operations. This capacity can lead to significantly downtime and lose productivity for organizations. Next, reboot. Infected computers may experience sudden and repeated shutdowns and reboots, which can severely disrupt normal business processes. This tactic can create chaos and impede the ability to conduct operations efficiently. Next, defense evasion. To avoid detection, adversaries often discuss their malicious activities as normal, expected network traffic. By doing so, they can operate with varying levels of stealth, successfully bypassing security measures in place. Next, distributor denial of service DDoS. Using a botnet, attackers can overwhelm a target server with a flood of requests akin to traffic congestion on a highway. This DDoS attack denies legitimate user access to the affected servers or website, potentially taking it to offline. So, hence, automation and customization, modern attacks, can easily customize and replicate a C2 node due to the availability of sophisticated automation tools. This technology, which was traditionally used by security professionals, make it easier for hackers to evade detection and execute their attacks. So, coming into the conclusion, command and control techniques are fundamental to modern cyber attacks, allowing hackers to maintain control over compromised system while executing various malicious activities. These techniques serve as the backbone of many sophisticated attacks, highlighting the need for awareness and understanding among security professionals. The three primary models of C2 centralized peer-to-peer random architecture illustrate the diverse strategies attackers employ to evade detection. Each model presents unique challenges and cybersecurity defenses, making it crucial for organizations to be prepared for various attack vectors. Attackers can execute a wide range of actions, including malware delivery, data theft, and distributed denial of service attacks, which pose significant threats to organizations of all sizes. The potential for operational disruption and data loss underscores the importance of effective cybersecurity measures. The rise of advanced automation tools has empowered cyber criminals to easily customize and replicate C2 node, thereby enhancing their ability to evade detection. This trend complicates the security landscape and necessitates continuous innovation in defense strategies. Finally, the robust security measures and a thorough understanding of C2 tactics are essential for effectively mitigating the risk associated with these attacks. Organizations must remain vigilant and proactive in their cybersecurity effort to safeguard their systems and data against the evolving threat of command and control attacks. So, dear learners, hope all you understood about C2 tactics and command and control techniques which is used in the spectrum allocations. The remaining things will briefly discuss in the next lecture. Thank you.